Hello there, it's Heider again. Another OMAP video on the OMAP series and the L138 LCDK board. I hope you find these videos educational and you might hopefully learn from them at some point. This video we're going to start, I think, from beginning of this video. We're going to build the project, and we're going to slightly gradually build on top of the same project. So on this video we will start doing the UART and the serial. If there's time in the video, we will do the LEDs as well, which is the 4 LEDs, not just one. I think TI only support 1 on the example set, but I'm going to do 4 at some point. And then we're going to build on top by doing the buttons, the switch. So switch 1 and switch 2, we'll see how to read them in a polling mode. And then the next video will be probably about interrupts and all the rest of it. So I think for now, to begin on the series, because I already have made a UART video in the past, this video tackles the issue differently. So rather than having the UART libraries added manually like we did in the last video by going to each directory and then locating the lib file, and then having a really difficulty finding out where the library is located and who's referencing it and the reference what and all the rest of it. We will do it in an easier way by having the configuration file. So anyway, the end result of today's video, well, 2 videos, I'm actually going to make this now. Well, put it this way, I've tried to create a previous video to this, but it's become too long. So I think what I'd like to say now is, if you are targeting how to or how we're going to operate on the LEDs and then get the LEDs to work, then probably skip to the next video, and that should really come up with the stuff that you need. And if you want to do the buttons and stuff, maybe we'll do in the video next video or the video after. So for now we will focus on the UART, doing it the easy or the RTOS way, if that makes any sense, and then we'll take it from there. So right click. Without further ado, we're going to do a new CCS project. Before I carry on, I'm going to switch the screen so that you guys can see what's happening in there. That's a better view. So now, this is the CCS. I'm using 11.2 at the time of recording this video. This is the OMAP that you just saw earlier, and this is moi, as you can see, and this is the serial output connection. So right click on the blank bit, new CCS project. And now obviously you can have the TMS 320 C6748. This is the technical name for the OMAP interface here at some point. And what we're going to do is YouTube test, or YouTube YouTube video. I'll just call it YouTube videos, or YouTube, let's call it project actually. The YouTube project, and this will basically start with a UART, then we'll build up on top and we'll create the button, the LEDs and all that kind of stuff. So we'll begin with this now. We'll keep that project, not going to move anywhere. This is literally for YouTube, right? So and I will I think, to be honest with you, just YouTube, yeah, easier, nice. Now keep things simple. We're not going to before we carry on, I'm going to just say C6748, or let's just call it an OMAP. Yeah, YouTube OMAP. So this is the OMAP interface of the OMAP project, YouTube. Keep things simple. We'll use the same compiler built in. We are not going to take anything else. So this is empty project with main.c. Really simple. And make sure your probes are installed. Just before we carry on, my probe is actually this one. That's the probe here. So it's a hardware. In case you wondered, it's not a software, it's actually a hardware, and it connects to the ribbon cable. And that hardware goes to a USB, and then your USB will use it as a serial port. So it's not really this one, or this one. It is actually this one. Anyway, so back into the screen. So now main.c. So we'll click verify, because I'm using the XTX100 or the Black Hawk. If this is not succeeded, do not proceed. So now we have it succeeded, then yes, it's good, it's correct. So and then finish. Very important, don't have spaces in your project. You will have it'll go badly. So just wanted to let you know that up front. Yeah. So now just to save time, I'm going to include stdio.h. Yeah. So stdio.h and or standard IO. This is to do the print and the manual, the input output for the stuff, and I'll do printf testing. Or let's just say system main started. Yeah, I think we've done that last time, but this is just a quick thing to let me just shut the phone down a bit. This is just a quick thing to show that the interface works at least. So if I just compile and run, yeah, I'll take it from there, see how it goes. If you have spaces in your project name, it will work for the printf test, but when it comes to the XC stuff, it will fail, because it will try to access it from the command prompt and it will have spaces in them all over the place and it'll actually choke out. So anyway, now you can see we have a success. So now the C67XX, which is the 4.8 main system started, so this is all good. It means this code did run on the OMAP itself, and it went through the console, but not through the serial here. So now we're good. Now what we're going to do is add stuff about the board itself. So what we're going to do now, let's just say void init board. And by the way, a lot of developers like to do this init board, but I like to do that. So I like to do you know, first capital of everything. I know it breaks Java and C, but well, it's not, doesn't break, it's just people like to do it this way. I like to do it the other way. I like to do, you know, my own functions have the first capital of everything. That's whatever. If you like to do it this way, that's fine. If not, that's up to you really. Really personal preference. It's nothing really special. Right. So anyway, when you're first starting to do this stuff, you do board init cfg, and then you call your variable, for example, board config, right? When you do the board config, you need to tell it what the board configuration is. So we'll do stuff in here, and then once you're done, sorry, semicolon, you will do board and then init, and then you do your board config. As you can see, really straightforward. And then when I do have that function, I really want to start that up here. So this function, this will printf the stuff in here, this will run this code in here, and this will set up the board. But now the board, we have the whole thing up and running, we need to tell it what to set up. So what you need to do, these are pretty much standard in most of the places. So you got the board, init, and then pinmux, mux, not mix, and then config. And then also you OR. That OR means additional option. It just means, for example, if this will have a number 5 and this will have number 9, it adds them together, or OR them together, and it becomes a 14, which means both are ticked at the same time. I can explain this in hex and bits if you like later on, but it's outside the scope of this thing. So board init, and then you got module clock. Sorry. Yeah, and the reason for that module clock is because I really like to, when I say delay for 2000 milliseconds or 2 seconds, the delay works. If you don't put that in here, the delay will not work. It'll just sound delayed, but it'll just carry on straight away without having to stop. So in the last one, board, init, and then UART stdio. What that is, this is a very important for our project, because what it is, if I tell the if I want to write stuff on the serial port without this thing in here, I will not see anything on that screen over here. So this will output or allow the board to talk serial to me, to my console. So now we got the stuff that we want to do, but as you can see, we don't have any of the classes or libraries or edge file or header files in there, which is a bit of a problem, because last time in order to do this we had to go to the includes, right click over here, properties, and go to the compiler, and then go to the include options, and then click here to add a directory, locate the header file, and then get back to this, and then we keep adding stuff this way. And on the linking side, similar story. We are in this video, we're pretty much going to change all that stuff now. It's not going to be the same, it's going to be a lot different than what we have previously done. This is now we're going to do this what's called the RTOS way, if you like. So anyway, now we have this whole thing set. We don't know where the libraries are, so I just wanted to highlight that point. I don't know where the library is. I know we should be doing this, or maybe it's some code you copy and paste from the internet, but this, you know, I've done this about 4 or 5 times, so I've pretty much almost memorized everything. Yeah, the pin marks, by the way, just to let you know, the pin marks basically is the configuration that tell the system. The OMAP has got the pins happening underneath, and the pin mark says, for example, pin 1 is mapped to this. It just tells us the board where each pin is actually mapped into. So for example, pin number 1 goes to the LED, pin number 2 goes to the VGA, pin number 5 or something like that. So this is all to do with how the ability for the board to define which pin goes where. So this is really important. And if you keep typing this in, this will become a cliche or a standard. So you're gonna have this over time. So just bear in mind, you can copy and paste it if you like to your own code if you want it. That's up to you really. So now the RTOS way. So if I'm going to File, New, and then RTSC configuration file, it'll create a blank file. I'm just going to call it YouTube OMAP. That's fine. I'm happy with that. Yeah, so I can call it YouTube OMAP. Whatever you want to call it, just as long as it have .cfg at the end, the system will know it's the config. So finish, and this is the magical bit that you're looking for. To build the blah blah blah, you requires XDC tools. Enable them, definitely you'll have to say yes. So this will enable XDC tools, and the difference now is when you right click, when you right click over here, properties, you will see XDC tools appearing here now. In the past it didn't. Now what we have on that side is the libraries or the includes that we want to include, which aren't there yet. Actually, it's actually came up quite nicely. That's interesting. So we go to General, and you go to Products, and here you really need to select your environment. So C6748 or the EVM C6748. When you apply and close, the C6748 is the technical name for this. Right? So now we have all the libraries coming up. Everything is running okay. Yeah, that's all good. And now, now we can find the libraries quite easier. So usually you look for the PDK. That's what you're looking for. The PDK is where everything should really be stored in. So PDK, TI, and you've got the board in there. So the board, that's to begin with. We need those two. So board CFG and board. So let's just go ahead and include them there. So just to include TI, just to highlight what I'm doing. So TI is here, 1 level up, and then board is the next level, and then the board itself in here. So ti/board/board.h, right? And I'm gonna do board_cfg.h. So now we have the two things to configure the board, right? And this is all, this should work absolutely fine. If I compile now, let's see how this is going to go. Nothing will happen, nothing different. It's just basically we are telling the system, you know, this is the board, and now we're starting to access the hardware slowly, bit by bit. Robert, turn it down, please, Shway. Thank you. Right, okay, so we've got some errors. Let's see what they are. Don't proceed, no, thank you. And let's see what's happening. So board init. Now we've done the header files on here, but what we haven't done is the libraries, or how to talk to the libraries. And notice we've just added a blank file on the CFG. I wanted to show you this because this will show that yes, I know we have board_cfg, but I don't know where the stuff that you're looking for example, board init, should live somewhere within the library of this one, but I can't find the library. So this is what the system is saying now. So to move on this side, we're going to add the stuff to the CFG file. So going back into here, notice, remember when we created this file here, the YouTube map OMAP CFG. If I double click, it'll show a blank file. There's nothing in there, literally blank. So I'll close it, and if I right click and then open with xgconfig, yeah, here we go. So on the board config, we have the SysBios, and this is the bit that we're looking for. So in any board, you take the SysBios in here, because we are using SysBios, and that's the whole point of this video, or this whole conversation. So now using SysBios, if I save the file and then look into the config, into the text side of it, this is what it did. It just added this line. That's all to it. So technically speaking, once you have finished configuration or done the whole stuff or whatever you want to do, if you go back to the CFG script, you can copy and paste it to wherever you want in a text pad somewhere, and then store it in a place. Once you're done with it, you can paste it back to any new project and it will work, because it pretty much because using the same board 99.9%, the configuration will apply to all your projects, hands-on anyway. Unless you are changing the board, you're going to have to change the settings. So this is how it works. That's why it's so easy. So you don't have to kind of right-click and add stuff manually over time. This is where you do stuff in here. So you just add them to the board manually bit by bit, and then you copy and paste into whatever thing you want. So now we have, so go back into this one and then back to this one. So now, in any board, you need to add a lot of things. So if I go to runtime, instrumented, non-instrumented, the difference, you need to check the manuals, but I'll just briefly tell you what it is. Instrumented means a certain log's enabled. These are grayed out. There will always a certain log. A log obviously stands for itself. It'll chuck text out when you want them to. The assert means if I ask it to sit on a chair and the chair isn't there, it'll stop the whole. It'll break the whole system. That's the assert means unless that thing is true or exists or available, terminate the whole application. And we really don't want that. Obviously, we're developing. We want that to be off because we'd like to see the errors and like to carry on this way. The non-instrumented one is the opposite. These will be disabled, but I think we'll do a balance. So we'll do a custom and then we'll switch this off. We're taking off the asserts and I want the logs on. And that's pretty much what I'm looking for. So that's pretty good. Save. And now I'm going to system overview. And here's the part where pretty much is like this is where your main screen going to be to access a high level. So now I have the BIOS ticked, as you can see here, that green little thing down there, but none of the other stuff are ticked apart from enable error handling. So that's now there. And notice BIOS has been added, program is already there, but we need to add stuff like memory. So memory will add, yeah, and going back into the SysBios, just waiting. It takes a little time because I'm actually recording on the other processors. Cache, add, definitely. We need cache support. And you've got the memory and the heap memory. I don't know if you have heard the term heap memory before and what does it mean. Memory you've got from here, 0, up till max, whatever it is. And this is basically where all your fixed stuff will be. For example, the file is 1 megabyte, it'll store it in there and run it. But the heap is the thing above the max into the other side of memory. So this thing, well, let's go back to the memory. When you load things up, it goes from 0 into the max. So it builds up on top like Lego, go upwards. The heap is the opposite. The heap goes from the maximum memory physically down to whatever red line, call it, between your memory and your heap memory. So this red line basically splits the heap from the memory, and the heap goes downwards, so it's like a little stack, and what happens is, it can be upwards, but it usually goes downwards anyway, depending on the architecture of the CPU. Let's just assume for the argument's sake it goes downwards, and it terminates until it reaches that red line in here. So what that means is the heap is very important. What that means is it's a memory that dynamic memory allocate on need. So for example, you could be it's like if you start up your, say, video recorder application, it stores it in there and all the variables goes in there, but because it doesn't know how long you're going to record, is it 1 minute or is it an hour, it'll say I'm going to allocate the heap. So the minute you start clicking the record button, it builds up the heap. So it'll take one chunk, stores it for the first frame, then the next chunk, then for the second frame, and so on. So the heap is our dynamic memory, keeps growing up based on your requirement. And once you're done, you just tell it, for example, freed up. I'm not interested in it anymore, and chuck it away. And that's how the heap works. So the heap is basically a dynamic memory allocation needed on on runtime, and the memory itself is a normal memory that is allocated on startup. So this is So now we have so now I have BIOS enabled. We have the memory, the cache, and the heap memory here. We need to allocate that as well. Don't worry about the variables inside or what sizes we need to configure that yet. We're not going that advanced yet. We're just ticking the boxes to make sure that these things actually do happen. Notice every time I tick something, it comes up in here, which means you can easily click and access it there. If I go back in here, the other bit that you definitely need, and just do this all the time without asking, go back to your chip support. So now mine is C674, and always add the event combiner. If you don't do that, you'll have a lot of errors in compiling. So this is definitely a must. You really need to add that all the time, and then take it from there. Yeah, so save. Right. Yeah, so now we have these things pretty much added. There are other bits that you really need to add as well. For example, your defaults, your diagnostics, your error, your main, that sort of stuff you need to add, but they're not here. But if you look underneath this side, where it says available product, you can see stuff in here. So if you, for example, click on the system there, you'll see a lot of stuff to add. So if you click on the defaults, for example, you tick this always. The reason you tick defaults, because for example, if you wanted to add another thing, for example, stack memory, which you haven't configured, it will say, oh, I haven't got stack, so I'm going to go to defaults and use defaults this way. So this is a really good, useful feature, and it's very, very beneficial for you to do. So system, always add system, don't argue with it. You can live without it, fine, but just add it. Just add it, why not? And main. Yeah, main added. I thought I clicked it, yeah, good. Yeah, so I think right, so we're good so far. The remainder of the stuff is let's add them in here anyway. You know, you got the, I would call it the three musketeers, the task, the clock, and the timer. Always add those in your design, because the task is really important. We're going to use the task to tell the system, I've got a couple of threads I want to run, so it's easier to do it here. And yeah, that's one thing. So task, clock, you know, speaks for itself. I need that clock there, definitely. And this is why we configured the clock when we set the board configuration. Timer, and I want that timer there. So I think with that stuff, we're ready. We're kind of ready. So now, just to explain what happened, so all these ticks I've been doing, just waiting for that to finish, and I'm going to save. It's doing the validation here, and as you can see, so it's validating, that's good. Alright, so all these ticks I've been doing so far is I've only done that. Literally. So to save you time next time from doing all that, these ticks and back and different screens and all the rest of it, you just copy paste this into your blank CFG file, save it, and then that's it. That's all you have to do. So now there is a what we need to add as well. You can add other stuff like the hardware HWI, which is HUI, the hardware interrupts and software interrupts. We'll add that in a different video, but for now I think we just want this whole thing to be up and running. So what you need to do now is, because we are loading up the board in here, we're going to do it this way. So we're going to add a var board, right, equals xdc dot load package, load package ti.board. Sorry, I've got that. Right? So ti.board, and also the board, it's probably dot settings dot board name equals, the board name is what you define, and just gonna run through this. You know, you don't have to memorize it, you can actually work it out. So I'll just explain what happens in here. So now you're on the board in here, right? So ti.board, and this is what you need to load. So we are loading this ti.board, which is great. That's all there. Yeah, and the board name. If you go to the SRC bit, and you'll see a lot of stuff in here. The one we are using at the moment is the LCDK. Where is it gone? Yeah, this is the guy we're using. So LCDK OMAP L138. So I'm going to type that in here. So LCDK, right? OMAP L138. Once. Don't worry, it's not COVID. It's just a sneeze. Right. Okay, so now we have set up the board. So we need to load up the board. So we load the package off the board and we set it up over here. This is the only thing we are typing in now. There are about 3 or 4 more to type in for the GPIO, for the UART and all the rest of it. So about 4 of those we're going to type in. But I think just to explain this whole thing, you know, the RTOS CFG file usually should display them in here, but I think the latest version 11.2 this has been broken, so now we're typing this in manual. This is what I've got from support, so this we're typing this manually here. Also the documentation said the same thing, to add that there, and if you want to search documentation, it's going to be there describing what happened. So it says either right click in here and add them this way, or you just copy paste from the manual, from documentation here. So to explain why you need to put that in, it's there under the SRC folder, and that's going to load up the stuff on this. So yeah, so this is one thing. Now this is the board bit. So now this is all good, but what we are missing, let's just load this up and see how it goes. So let's just carry on. So now I've got the board configured, we've got pretty much the whole lot there. Technically it should compile, but the only time it wouldn't compile if the board requires some stuff that's not been dealt for. Usually these are the chip support libraries, which is the CSL bit that we have to load up as well. So this is what we're going to do in a minute, but I think for now, let's see how this is going to go. So now we're at 18% compiling, see how that's going to go. Well, again, this video is to explain to you, without right-clicking on the project and adding stuff this way, how to do this without right-clicking. This is all to do with the configuration. And again, once you're happy with this configuration, copy-paste it into your text file and then paste it this way. So now we have another error. Let's see what's going on. No, don't proceed, don't load this up. So let's see, coming down, linking. Yeah, that's fine. Lib, library not found. There we go. So TI-CSL, and as I just literally said that, the CSL, the chip support library, isn't loaded. So we need to load that up as well. So to load the CSL, we're going to load the package as well. Same thing, I'm just going to copy paste that in here. So we're going to do CSL, right? And we're going to load package CSL TI.CSL. Same thing, but this time on the CSL it requires device type. So board.csl.device type, and likewise OMAP L138. In the same way, the device will be there as well. So this one is the LCDK, this is the CSL, that way. So if I go back to CSL, I'll explain this more, in case you got confused to see why we're having LCDK and why we're having OMAP. In board, on the SRC, it does that. But on CSL, let's go into CSL there, right? And SRC, no sorry, and the lib, I'm pretty sure. Yeah, there we go. On the lib, it's looking for the OMAP L138. So this is what it's looking for, the device type. Yeah. So now we have these things done, and now I can compile again and take it from there. this time I think it's gonna carry on. It's gonna compile nicely. Let's see. Beautiful day, really. Very nice. Okay, let's see what the error is. So we got another error here. Don't proceed, download it. So what else it needs? XTC tools. What else is looking for? Not here. Yeah, that's an error there. JavaScript. No element name device type. Aha. Yeah. Okay. Device type. Hold on. Oh no, sorry. Look at this. It's crazy error. So we copied the lines into here. We didn't fix that. So CSL. We copied that, but we didn't change it in here. So CSL.settings.device name. That makes sense. Yeah. Sorry, that's my fault. Sorry. Let's carry on again. Deploy. As you can see now, we added the types, we added the name, the board name, the device type. So we're building it up this way, and the system using the CFG file actually knows which libraries to go and get. And that's a huge difference to the one we did last time. So now we're on our way. So now 20%, we've done more. We should be up and running soon, I suppose. Yeah, probably OSAL may be missing, we'll see. See that now things are linking. We are down the food chain, so get in there hopefully. I think I need to slightly dim that window a bit. Might be better, is it? Yeah. Anyway, so for maybe the window open should be better. Yeah, for the past 4 weeks, I think I've been working. I've been with my friend who visited me from the US. He's one of my best friends. Quite like him a lot. We have a good times all together. So I haven't seen him since COVID, but yeah. So we spent a nice 4 weeks together. Went out, so I had no time to spend in here. So now I'm actually having the time. So I'm back to kind of tackle this up. So hopefully that might help someone. As I said, we are starting the configuration file this way. We're not going to add things manually, and we're going to build things on top as we go along. So this is the first video we're going to start, and you keep in the same video, a YouTube project. We're going to build on top of that later on. So I think what we'll do, we'll reach out the UART bit, and we'll stop right there. But for now, let's just see what we're doing. Yeah. So now there's another error, and I just saw. I know what's happened. Just waiting for that thing to release. Yeah. Okay. Now, let's see. Okay, cancel. Right. Okay. So we got a few errors in there. So the range overlaps. What that means is you've got two forces on the system. One force that says I want to use this memory for my deployment, and the other force is trying to say the same thing. So the memory cannot be split into half because the linker is saying I'm taking over the memory, but the compiler is saying I'm taking over the memory, or using a script. To fix this, go back into here and just tell the compiler not to be too clever. So properties, and this bit in here. This is what tells the system I want to lock the memory down, and you want that off. You don't want that in. So say none in here. Apply and close. So that fixes one side of the problem. The other problem I just saw is another thing. Where has it gone? There's another complaint about this guy, UART config here. So UART config, are we using that? I thought we did. I don't think we'd use that. Yeah, we didn't use UART config. But it looks like the board, you know, the UART is referencing it for some reason, so it needs that at some point. So what we're going to do, we're going to tell the system, let's load up the UART drivers anyway. So going back into here, and we'll just copy these, and I think there's a difference in here now. Let's call this UART, and not to make the same mistake, UART, right? And then here there's a difference. So anything on the TI directly like this, TI like board, CSL, FS, OSAL, all that stuff, you load them up using a load package. Anything on the DRV, which is what we're looking for this example UART, is we're gonna load using a use module. So here we're going to say use module, and this time is ti.drv.uart.settings. Yeah, and on the UART type equals the same as the device type in here. Yeah. So that's the third bit, and yeah, I mean, to be honest with you, what we can do also, just I don't know if you know this or not, we can say var device name equals that same stuff, and you can say 1, 2, yeah, and also you can also say here the same way, var board name equals like this. Yeah, so this is for you to change later on. So say for example you wanted to migrate your code from the OMAP into the AM5728. You just change these things over here. You don't have to go through the whole code, you know, wondering what the heck's going on. So this is all easier for you to do. So now we have the SOC type is done here, and because you're using the UART, I know for a fact you need to use the OSAL support, which is OSAL. Where is it going? So DRV, you the OSAL layer as well. And yeah, so we're going to use module ti dot OSAL dot settings, and this OSAL here it requires the SOC type, and it also requires the OS type. And the OS type is the TI-RTOS bit. So let's just say OS type and var TI-RTOS, right? So I know you're probably thinking, what the heck's going on? It's too much to type in. But the good news is you're only going to need to type this in once. You don't have to worry. Type in this once, saving it in a file somewhere, then you can come back to it and then paste it to any new project you like. It's a really, really good thing to do. You know, so we got the OS type in here, the device name, so it's pretty much we're good to go. So we're going to run this code again. Now, technically, there should not be any problem whatsoever. It should just compile and run straight away. And we'll see now. let's see. So now I think we recorded 45 minutes so far. Yeah, I think we'll what we'll do now, because we've added the UART, so we'll just write quickly on the UART to say hello world, that sort of thing, and we'll end the video, and then we'll carry on the next video to build on top of this project. So it's going to be a series, and we're going to take it from there. I think it's going to be a lot nicer to do it this way rather than creating a 10-hour video. I mean, 45 minutes is pretty dry, I think, anyway. So yeah. So now we're linking. I think we're looking for the happy ending, hopefully. I think it's, well, it shouldn't really, you shouldn't need GPIO for this one. Shouldn't be. We'll do GPIO in the next video, hopefully. Yeah, so that's fine. Yep, finished building, good, linking, let's see, moving on. Build finished, wonderful. So now we should see that thing deploying soon. Yeah, I think we're good, have 100%, happy ending, happy days. Voila. Right, so that worked, but you didn't see much difference. So let's make it slightly more interesting. So now we've configured the board, right? So if we configured the board in here, what we can do is you can say UART print F, and let's just say UART printing on serial, yeah, printing on serial, or let's just say working on serial now. I'll take that thing off. And I'm going to say /n for a new line. Same thing in here. Always do that /n bit and add the semicolon at the end. And we'll compile one more time. So now it should just work. We will have, keep an eye on this black box in here, this one. Once we compile and run, this, sorry, the black box in here I meant, yeah, I just pointed at the window. Once we compile and run, this should come up with a UART display, so we'll see. Oh, sorry, we're going to have an error. Do you know what's missing from the code? I bet you don't. It probably would work, but let's cancel it. I don't want it to have undesirable effect. UART printf is something that should really work and is a standard thing to do. Come on, what's happening? Go away. Yes. But the problem is, I just noticed this one warning, and that explains it all up. UART declared implicitly, which means there you're trying to use something, but you haven't tell us what the library is. Although the library would work, but we need to reference it from here. So, whilst I'm doing this, just you know, I call it like a quiz if you like, for you to find out where is the UART libraries. Again, the answer is PDK, TI, and DRV. We've done this before, and then UART, and it should be UART SCDIO. So what we'll do here, let's just put a blank line and the one underneath to know that we are using a different batch. So TI, DRV, yeah, UART, UART stdio.h. Did I get this right? Let's just check again. So TI, DRV, UART, UART stdio.h. Oh yeah. So now if I run, it shouldn't have any warning whatsoever. So fire up. Let's see. The warning should disappear now, and we should have a happy ending. But anyway, if you look at that, system main started. This is when we when I start to the compiling. But always make sure you are referencing the right libraries or the header files to begin with. Don't just depend on libraries, even though libraries would work with CFG. But just make sure you haven't got these warnings to say implicit. Implicit means you haven't done. So anyway, there we go. UART working on serial now. So this basically no warnings, no errors, and the whole thing is nicely working happily ever after. And he also got the system main started, so it's a really good ending, and that's what we're waiting to achieve. So this is the video. I know it's a similar video to the last one we did last time, but this now we are building on top of that. So the next video that's followed this one, which I'm going to upload soon, or going to record and upload soon, is going to start taking this example here of this project, build on top of it, and then add the GPIO and the interface for the lights and the key read as well, and it'll be a nice thing to actually have a look at and learn from. So again, now I just wanted to well, thank you for watching. I know the video is now 51 minutes and 20 seconds. Ugh, yeah, sorry. I hope you learned from this video. Again, I don't know if I've said this before, there's not many videos on how to do the OMAP and the interfacing, to explain it in this way, and I'm hoping that this will help you out. Also a message to Texas Instruments. I mean, really great devices, brilliant devices, but the problem with these devices is that you got a really beefy, nice hardware, and not a great support on the software side. And I caught in particular an incident I had with 5728, where it was confirmed officially that this release has broken this stuff and this and that, and that breaking down has been down for a while, and there's not much update on it. So I think having to revert to a previous release to do stuff isn't, hopefully maybe someone will pick this up and then start. I mean, I'm happy to help myself if necessary, but anyway, let's not go there. Just wanted to thank you, TI, for such a wonderful company. I like TI a lot, Texas Instruments, and I'm using your products, and yeah, hopefully we'll add more videos as we go along, and then people will start to understand what TI and these products do. So we'll take it from there. Have a nice day, and thank you for watching the video. See you later.